Hi students, we have already started the determinants. So here I will cover the next part of the determinants only. So the point is, if the rows and columns in a square matrix are interchanged, then the value of its determinant remain same. Okay. So if the rows and columns in a square matrix are interchanged, then the value of its determinant remain same. Means, as I have already told in the previous lecture, that the determinants of a square matrix is equal to the sum of the products of the elements of a row or column wise with their corresponding cofactors. So in the same process, you will calculate the determinants, right? So if you will change the rows and columns, then there will be no issue to calculate the determinant. It will be always same. So determinant of A and determinant of A transpose. Transpose means interchanging the rows and column. So the determinant of A and transpose of determinant of A will be same, right? The next point can be the determinant of a square matrix changes sign when any two rows or columns are interchanged. Value will be same, but the means when you will do the interchange, okay, any two rows, okay, in that case you the sign will be different. So I'm writing that one. The determinant of a square matrix changes sign when any two rows or columns are interchanged. The determinant of a square matrix changes sign when any two rows or columns are interchanged. Okay. So the next one is, if two rows or columns, okay, of a square matrix are identical or proportional, then the value of the determinant is 0. So if two rows or columns of a square matrix are identical or proportional, then the value of the determinant is 0. Okay. So next point, if all the elements of a row or column of a square matrix are multiplied by a number like k, okay, then determinant of resulting matrix will be k of determinant. A means it will be k times of the determinant A. Okay, when all the elements of the row or column of a square matrix are multiplied by a number like k. If and next is if each element in a row or column of a square matrix is the sum of two terms, then its determinant can be expressed as the sum of two determinants of two square matrices of the same order. Okay, I'm just giving the example for this. I'm not writing a1 plus x. Okay, then suppose b1 plus y. Okay, then c1 plus z. Okay, and here a2, here a3, then b2, then b3, then c2, then c3. Okay, that can be written as in this way, like a1 b1 c1 a2 b2 c2 a3 b3 c3 plus x, y, z, a2, b2, c2, a3, b3, c3. Okay, this one. Next one is like if the elements of a row or column of a square matrix are added with the k times then the corresponding elements of any other row or column, then the value of the determinants of the resulting matrix will be also unaltered. Okay, like x1 x2, then x3. Okay, then suppose y1, then y2, y3, then z1, z2, z3. It is also equals to like x1 plus k of y1, x2 plus k of y2, x3 plus k of y3. Okay, this is y1, y2, y3, then z1, z2, z3. Okay, so basically if the elements of a row of a square matrix added with the k times of the corresponding elements of any other row. So here I have done like this is one row and I am adding the first row with the k times of the second row for each element. Okay, then the determinant will be unaltered, it will be same one. Okay, The next one, so the sum of the products of the elements of any row or column of a square matrix with the cofactors of the corresponding elements of any other row is 0. Okay, like suppose determinant, this is a1, this is a2, this is a3, then b1, then b2, then b3, then c1, then c2, then c3. Okay, so if I will do like the elements with its cofactor, then the b1 with its like this these elements with the cofactor of the corresponding elements. Okay, so I have taken the corresponding elements cofactor. So b1 then b2 plus c1 c2, this will be 0. In the same way, like a1 a3 plus b1 b3 plus c1 c3, it will be also 0. Okay, so next if you will take as like a2 and a1 means first two rows, so a2 a1 plus b2 b1 plus c2 c1, this will be also 0. In the same way, if you will take the second row and third row, so a2 a3 plus b2 b3 plus c2 c3, this will be also 0. In the same way, you can write for the other rows as well. Okay, so that's for all for this lecture. So again we will meet in the next lecture.